Razor kinematics, I could talk about razor kinematics for a long, long time because I am one of the co-inventors of razor kinematics, and I am always very proud to show results. And I will tell you a little story on how razor kinematics, what it is and how it emerged. When I was moving from the Tevatron to the LHC, one of the most difficult searches for supersymmetry and dark matter is the search that it is giving you a lot of missing energy. In other words, stuff you don't see. Now, the missing energy can come from neutrinos, which are standard model particles, but the search we're going for is for the dark matter heavy particle, which we cannot detect, hence the missing energy. In trying to re-engineer the analysis so that the difficulty of having the signal looking very much in its shape like a background, I made up a homework. And at that time, a student appeared who really took up the challenge, and it took many years, but the razor kinematics was the result of the homework. What it does is that for the case of two new heavy particles pair produced that will then go back to back and they will decay into other particles, including the dark matter, one on this side and one on the opposite side. If you go on the decay chain and you start moving the reference frame of the calculation to be on top of the heavy particle, you are going to produce the razor variables, the razor kinematic variables that will give you a better sense of what it is the mass of those two particles that you directly produced and the mass difference between those and the dark matter particle. So we went from with doing the razor kinematics, the leap was so big as from the radio to the iPod. And then we had a sense of upgrades of the razor kinematics, where we did the same boosts, Lorentz boosts they're called in the calculation, and we followed every particle in its decay by doing this type of boosts, so that you can get a better sense of which kind of approximations you can do, so that the kinematics are very different from the kinematics of the background, and you see the signal as a peak on top of a dropping noise of the background. Now the homework, I give the homework now to first year freshman undergraduates at Caltech, and they solve it. So this, in the time of 4 years, the razor has become a tool that everybody is using, theorists, phenomenologists, and experimentalists. And we were 4 people, 2 senior people, one junior faculty at CERN, Maurizio Pierini, and my student, Chris Rogan, who went to Harvard after that are the inventors of all the razor, of this razor framework. So I'm very proud of that.